So what if a small, open-source robot could help solve some of the biggest challenges in farming? Well, that's exactly the idea behind the Smart Agribot. It's an autonomous rover that's designed to be a farmer's eyes and ears right there in the field.
Now, I know what you're thinking. It looks like a simple little rover, but its mission is absolutely huge. I think the project's tagline says it all. Small robot, big harvests. It's all about using technology that's accessible to everyone to make a really massive impact on how we grow food. So why even build a robot like this? That's a great question. And to really understand the why, we've got to start with the real-world challenges that farmers are up against every single day.
I mean, farming is a constant battle. You've got pests that can just wipe out an entire crop. You've got the critical, constant pressure to conserve water. And then there's the high-stakes guesswork of knowing that perfect moment to harvest. Traditionally, trying to manage all of this means walking the fields, checking things by hand. It's incredibly time-consuming, and honestly, it's often imprecise.
And this is exactly where the Agribot comes in. Now, it's not some kind of silver bullet for everything. Think of it more like a highly specialized expert, an autonomous field scout that's designed to tackle those very specific problems we just talked about. When you look at these designs, you really get a sense of the philosophy here. The bot itself is built from accessible, off-the-shelf parts. But the real magic, the secret sauce, is when you pair that simple hardware with some pretty sophisticated AI. That's what turns a simple observation into powerful, actionable advice.
Okay, so how does it actually work? Well, the whole process kicks off with gathering raw data, straight from the source, the field itself. This is the foundation that everything else is built on.
You can almost picture it like it's on a constant patrol, right? Its main job is to just move through the crops, using its sensors to watch, to listen, and to record. It's creating this incredibly detailed digital snapshot of the farm's health. The bot's main eye is something called the ESP32 cam. It's this small, really low-cost camera, but its job is critical. It's capturing all the visual information, looking for those tiny, telltale signs of pests on a leaf, or checking the color of a fruit to see if it's ripe. But the camera is just one of its senses, It also uses a soil moisture sensor to check if the ground is thirsty. It's got another sensor for air temperature and humidity. And of course, it's got Wi-Fi to send all of that valuable data up to the cloud for processing. All right, so the bot's collected all of this raw data. But data is just noise until you can actually make sense of it, right? And that brings us to the bot's digital brain, where the artificial intelligence comes in to find the patterns that matter. This whole process is basically a data-to-insight pipeline. The bot snaps a picture, sends it up to a server, and then two specialized AI models get to work. One is an expert at detecting pests, and the other is an expert at checking for ripeness. It's like a digital assembly line for agricultural analysis. The first AI specialist is called YOLO V8. It's an object detection model. The easiest way to think about it is like a digital pest inspector that's been trained on thousands of images. It can instantly spot and draw a little box around specific threats, like an aphid or a beetle, that the human eye could easily miss. The second specialist on the team is MobileNet V2. This one's a classification model. Its job is a little simpler, but just as important. It looks at a picture of a fruit and just categorizes it into these clear stages. Is it unripe? Is it perfectly ripe? Or maybe has it gone a bit too far? This completely eliminates the guesswork for the farmer.
So, the AI has done its analysis. It's found the pests, it's checked the ripeness. But what's a farmer supposed to do with that? They don't need raw data, they need simple, clear advice. This final step is all about translation.
This little snippet of code gives us a peek into how the bot actually thinks. It doesn't just look at one piece of data in isolation, it combines information. If the soil moisture is low and the weather forecast shows no rain, then it generates a recommendation. Irrigate now. It's simple logic, but with a really powerful outcome.
And this right here, this captures the entire goal of the project. You've got all this complex engineering happening behind the scenes, but it's all intentionally hidden. What the farmer gets is just a simple, clear, and incredibly useful tool. So now, let's just zoom out for a second. What does all of this mean for the bigger picture? What's the real-world impact when you put a tool like this into the hands of farmers everywhere?
Well, the benefits are very tangible, and they are significant. By watering only when you need to, you drastically cut down on water usage. By targeting pests with precision, you optimize how much pesticide you use, which is way better for the environment and the budget. And both of those things lead straight to the ultimate goal: healthier plants and bigger crop yields.
Plus, the system is designed to just slot right into a modern workflow. Farmers get a live dashboard to see everything at a glance. They get automated calendar reminders for jobs like spraying or harvesting. There's even a chatbot for quick questions. And, of course, you can export all the data for a deeper dive. It's really a complete toolkit.
So as we wrap up, I just want to leave you with this question. We've just been looking at one open source bot, but imagine this technology scaling up. What does farming look like? What does our entire food system look like when every farm has a whole fleet of these tiny, intelligent helpers working around the clock? The potential is, well, it's truly staggering.